Ooh, quite cold out here, huh? Did you know that, unlike us, some fish can tolerate very cold waters? Before diving, metaphorically speaking, into this thrilling topic, let me remind you of our TP page, where you can support us by making a donation at your own discretion. It would be a tremendously appreciated Christmas present and would allow us to upgrade our underwater equipment. Of course, subscribing to our channel helps too, so don't hesitate to click on the red button and on the bell. Oh, thank you so much! Okay, now we're ready to start indeed. First of all, we need to know that most fish are ectotherms, which means they aren't able to control their body temperature. In fact, they have the same temperature of the surrounding water. For tropical fish, this is pretty cool. But what about Arctic and Antarctic fish, which live in freezing waters? Very often, the temperature of polar oceans is below 0 Celsius, but they maintain liquid status due to the presence of salt in the water. So how can fish blood remain liquid too in such conditions? The answer is easy. These fish possess AFPs, anti-freeze proteins. Such proteins prevent blood from freezing, acting as inhibitors of the growth of ice crystals. In simple terms, they act just as the antifreezing liquid you put in your car engine. There are 4 types of antifreeze proteins, depending on their structure. Through a combination of X-rays and neutron diffraction, researchers have examined the structure of type 3 proteins in particular, to understand how they interact with water molecules. They found out that the structure of these proteins differs from that of other proteins, and this characteristic allows AFPs to bind differently to liquid water rather than ice crystals. These proteins are very smart. They manage to identify those crystals, stopping their growth. Incredible, isn't it? In the following tables, you can find some examples of fish which own these peculiar proteins. We have fish with type 1, type 2, type 3, and finally, type 4 AFPs. Antifreeze proteins seem to have many applications, especially concerning food conservation, because they can prevent ice crystals damage, avoiding the rupture of cellular membrane and the subsequent loss of intracellular fluids, which would alter the food texture, making it mushy and unappetizing. But that's not the only use, and further investigating these proteins could prove to be a precious asset in many fields, for instance cryosurgery, cryotherapy, fish farming and plant cropping in colder environments. There is still a lot to discover. Thanks for watching! If you liked the video, leave a thumbs up and share it with as many people as possible. Subscribe to our channel, you won't regret this. Now I'm gonna go warm up a little. See you in the next episode.